All right, I just want to go over this problem 2.2, this characteristic diffusion distance. So if we were to take a look at problem 2.1 to base our solution off of, you can see that we're using the error function solution. And if we rearrange the error function solution with our known quantities, we get this equation here. And then if we were to go ahead and plot this for 3 different times, 30 minutes, 2 hours, and 5 hours, we would get the curves that are shown here. So this is our error function solution, and this is the plots that you should have had from problem 2.1. So if we were to take these 3 values and calculate this quantity, x equals the square root of dt, okay, so let's go ahead and do that. X equals square root of dt. For the half hour, 2 hour, and 5 hour case, we're going to get these 3 different depths, and that corresponds to these 3 lines on here. And if we go ahead and find the intersection on our 3 time curves, you can see that they all actually intersect at one value very close to 0.7. Okay, and so it looks like this characteristic length, x equals square root dt, corresponds to a value that's halfway between the surface at 1.2 and the initial value at 0.2, right? Between 1.2 and 0.2, we would have a value of 0.7. So it's approximately half of the concentration difference between the surface and the initial values in the bulk. And so that's what this x equals square root dt, it's referred to as a characteristic length because it gives us the value where the concentration is about halfway. This would be a good measure, for example, for case hardening. If you wanted to know the case hardening depth at, say, 30 minutes, you could do a quick x equals square root dt, and you would get this depth here, 5.5 times 10 to the minus 4, and that would correspond to where you've increased your concentration from the bulk to about halfway to the surface for the 2 hour characteristic lengths for the 2 hour and 5 hour case. Okay, the exact numbers for Cx end up being 0.68 for these values, and the relative concentration value between the surface and the bulk ends up being about 0.48 instead of 0.5, but this is pretty close. And so quick calculation that gives you this depth at the halfway point for any given time.